Good evening, Titans, and hopefully you're having a great weekend. And we're going to talk about lesson 3.2 today, and titled Linear Functions. So the essential question is, how can you determine whether a function is linear or non-linear? So if you just think about it, linear, a straight line. Non-linear, okay, so pretty simple. We want to know, is a graph or an equation or whatever going to represent a line or something nonlinear? Here is a slide of definitions. I'd like you to put these definitions in your notes. I'll talk about a couple of these, but a few of these we'll talk about later in the video. So, first of all, a linear equation in two variables. An equation that can be written in the form y equals mx plus b, where m and b are constants. So again, that's going to be very important. This form is how we're going to write our linear equations. A linear function is a function whose graph is a non-vertical line and has a constant rate of change. Okay, it must have a constant rate of change, which means it's going to be a slant that's constantly changing at a constant rate, the same rate every time. Nonlinear does not have a constant rate of change. So something nonlinear is something like this. This does not have a constant rate of change. Okay? A solution to a linear equation in two variables is an ordered pair that makes the equation true. And then discrete, you can write this down now, and a continuous domain, you can write those definitions down, but we'll talk about them later in the video. First of all, if we look at this graph, which one's linear, nonlinear? Well, that would be nonlinear. And this graph, because it has a constant rate of change and it's a straight line, that would represent a linear graph or a linear function. Here, if we look at the x's, it increases by 3, increases by 3, and increases by 3. Here the y is decreasing by 6, decreases by 6, and decreases by 6. So as the x values were increasing by 3, the y values are decreasing by 6. This would be a constant rate of change, which would make this linear. In the next one, the x's are increasing by 2, increasing by 2, and increasing by 2. But here, the y increases by 7, and still, again, as x increases by 2, now it increases by 11, and again, as x increases by 2, here the y is increasing by 15. Since these are not constant, and these are, this is a non-linear function. So now we want to know, do these equations represent a linear function? Now remember, linear functions must be able to be written in the form y equals mx plus b. And again, it's very important to recognize that the x is just the variable x every time. There's not an exponent, there's not a radical sign. The variable is in the numerator. So if we take a look here, this first one, y equals 3.8. Well, one, there's not an x variable, but I could do y equals 0 times x plus 3.8. So I can still identify that my m is 0 and my b is 3.8. So then, yes, that's linear. The next one, y equals the square root of x, is not linear. It's the square root of x. Here, the variable x is the exponent. Again, not linear. Here, the variable x is in the denominator. If I try to move it to the numerator, it becomes x times y equals 2, which again cannot be written in the form y equals mx plus b. So that's not a linear function. The next one, if I distribute the 6 through, I get y equals 6x minus 6. And again, I could write it as y equals 6 times x plus a negative 6 if I really got technical here. And so y equals m times x plus b works. So the m is 6 and the b is a negative 6. So that is a linear function. And the last one here, again, the x is to the second power, so that's not a linear function. Now, if we look at this one, is this a linear function? Yes. I can rewrite it as y equals 1 times x plus 9. So I can identify my m to be 1 and my b to be 9. This one is y equals 3 times x all over 5. Well, I could rewrite it as y equals 3/5 times x plus 0. And again, I can identify my m to be 3/5 and my b to be 0. Now here, because again, the x is raised to the second power, that's non-linear. That's a non-linear graph. So, there are several ways to show a representation of a function. We can just use words. An output is 3 more than the input. So for example, if I say that the input value is 2, well then 3 more than that, the output would be 5. Here we have it as an equation. If I plug in 2, 2 plus 3 is 5. Here we have it as an input-output table. Here we have it represented as a mapping. And then lastly, as a graph. Now, this is where we talked about in the very first slide and writing down that definition of a discrete domain and a continuous domain. A discrete domain is a set of input values that consist of only certain numbers in an interval. So here, for example, they have the integers graphed from 1 to 5. So for example, if your mom said, hey, run to the store and you must come back with 1 to 5 eggs. So you have to buy at least 1 egg, but she doesn't want you to buy more than 5. So the reason we put just the dots on the number line is because we can't buy part of an egg. You have to buy 1 egg or 2 eggs or 3 eggs or 4 eggs or 5 eggs. You can't buy part of an egg, which is why we use just the dots. Now if we look at a continuous domain, well, let's say you go to Orange Leaf and they say that you must buy at least 1 ounce of yogurt, but you cannot buy more than 5 ounces of yogurt. Well, when you're filling up your yogurt cup, you don't know exactly, you don't have to buy exactly 1 ounce or exactly 2 ounces or exactly 3 ounces. They'll measure it and then they'll charge you. So again, since we're able to buy different amounts of yogurt, then we have what we call a continuous domain. Here we take a look at this table of values. And they ask us, is this domain discrete or continuous? Well, if x represents the number of stories in a building, can you have part of a story if you're building a house or building a building? No. So this is be a discrete domain because I can only have whole number values. This would be a discrete domain, and this would be a continuous domain. Now, what I'd like you to do is, for the Now You Tries, go to your extra practice in your student journal, and from lesson 3.2, okay, make sure you're on lesson 3.2, and work problems 1, 3, 5, and 7, and we will check these tomorrow in class, all right, or Monday in class. Hey, I hope you're having a great weekend again, and stay tight and true, and good night.